Alright, in this mini lecture we're going to add and subtract rational expressions. This is part 2 because in part 1 the expressions had like denominators. However, in this part our expressions will have unlike denominators. So if you think back to elementary and middle school when you add added and subtracted fractions and they had unlike denominators, you had to find what's called the LCD. So we do the same thing here. The LCD is the least common denominator. So we'll find that first. First, to do so, we're going to factor each denominator completely. You must completely factor all of your denominators. Any factors that occur multiple times should be expressed as a quantity raised to a power. So we can write down all the different factors that come up in the denominators, and if the factors repeat, we write it with the highest power that it's seen with. The LCD is then written as the product of all of the factors from that previous step. So let's show what all of that means. Our first example may be something like 7 over x plus 3 over y. As you can plainly see that the two denominators are unlike. They're unlike. So we can't handle this the same way we did in part 1. In part 1 they would have been similar and we would have just added the numerators and wrote them as a single fraction. However, in this one we see x and y. So there are two different denominators. This one may be a little bit more straightforward than the next few problems, but we'll start slowly. And since those are different, x and y, the LCD is a product of those both. So the LCD is xy. Alright, what do we do now? Now we rewrite both of these fractions. I'll write one right below this first one and right below this second one. Now we rewrite them with the LCD. And let's see, how do we figure out the new numerators, right? If you remember back to arithmetic, when you had an LCD, you would go ahead and figure out the new numerators. So same situation here. We're going to multiply 7 times something and this 3 in the old numerator times something to make a new numerator. So what do we multiply by though? So let me go ahead and take the LCD of xy, right? And I'm going to just divide it by that old numerator of x. If I do that, what am I left with? I'm left with a y. So that's what you'll multiply that old numerator times, y. Same thing, let's do that again. I'm going to take this xy, the LCD, and divide it by that old numerator of that second fraction, that second rational expression, which is y. So when I do that division, these cancel out and I'm left with x. So that x is what you'll multiply times the old numerator to come up with a new numerator. And our new numerator for the first one is 7 times y, which is 7y, and it's still over xy. And the new numerator is 3 times x, which is 3x, and that's still written over xy, the LCD. Now they have the same denominator. We've already figured out the new numerators, so now it's similar to the problems in part 1 where we write them as a single fraction. So now we have 7y plus 3x over xy. Well, from the way it looks, I can't combine those. Those aren't like terms, so there's nothing else I can do, and that's our solution. Alright, let's give another one a try. So let's say we have our example that says 5 over 4x squared y plus 3 over 14xy to the third. Alright, so plainly we see that the denominators are different, so we need to find an LCD. Well, of the numbers 4 and 14 have an LCD. The smallest number that 4 and 14 can both evenly go into is the number 28, right? 4 goes into 28, 14 goes into 28. 28 is the smallest possible number that they can both go into evenly. We see they both have x's in common, right? One's x squared, one's an x. So therefore, we take the one with the largest exponent, as I stated up in the steps above. And they both have y's in common. So y is an LCD, but we said we take the one with the largest exponent, which is the 3. So the LCD is 28x squared y to the third. Now I'm going to rewrite these expressions, rational expressions, with the LCD that we've just found, 28x squared y to the third and 28x squared y to the third there. Alright, so let's figure this out. How am I gonna know what to multiply this 5 and this 3 by? Well, here's how we do it. We take the LCD, 28x squared y to the third, and you divide it by that old denominator. The old denominator was 4x squared y. What do you get when you divide that? 4 goes into 28 7 times. The x squareds cancel. Y to the third over y to the first makes y to the second. So I'm going to multiply the 5 times 7 y to the second. Alright, let's try it again for this other side. We take that LCD, 28x squared y to the third, and we're going to divide it by the old denominator. The old denominator is 14x y to the third. Well, 14 goes into 28 2 times. X to the second over x to the first makes x to the first. The y to the thirds cancel out, so we just have a 2x. So we're going to multiply that old denominator of 3 times the 2x to create our new numerator. Alright, so 5 times 7y squared is 35y squared over our LCD, 28x squared y to the third. 3 times 2x is 6x over our LCD, which is 28x squared y to the third. So we've created our new numerators and we have them over the LCDs. So we see that we have like denominators. We can write them as a single fraction over 28x squared y to the third. And now we're just going to add the two numerators. Well, we have 35y to the second plus 6x, and I look at them, they're not like terms, so there's nothing else I can do, and that is our solution. Alright, let's go with another one just to make sure we're all on the same page. We have x over x plus 5 minus, so it's a subtraction, of rational expressions, minus 2 over x minus 3. Alright, so we have to figure out the LCD. Well, one denominator is x plus 5, the other one is x minus 3. Those two quantities are different. They're different, right? They're together. X plus 5 is together with the x minus 3 is also together. They're different. So since they're different, we write them as a product, as stated in the initial steps. So our LCD is x plus 5 over times x minus 3. So now I'm going to rewrite these with my LCD that we've just found, x plus 5 over x minus 3, x plus 5 over x minus 3. And again, I'm going to multiply this x, the old numerator, times something, and this 2, that old numerator, times something. But times what? So let's figure that out. I'll take my LCD, and eventually you'll start doing this more and more, and you'll be able to do this part in your heads. But for now, we'll go ahead and write that out. No big deal. X plus 5, x minus 3, and we divide the LCD by the old denominator, which is x plus 5. When we do that division, they cancel out, and we're left with x minus 3. So therefore, we're going to multiply that old numerator of x times x minus 3. Let's figure out what we're going to multiply this 2 times. Again, we take the LCD, x plus 5, x minus 3, and we divide it by the old numerator of just x minus 3. Well, those cancel out, and we're left with x plus 5. So therefore, we're going to multiply that 2 from the old numerator times the x plus 5. Alright, so let's go ahead and do that. When we multiply monomial times this quantity, this binomial in here, we have to distribute. So we have x squared minus 3x over our LCD of x plus 5 times x minus 3. We distribute 2 times x and 2 times 5. We get 2x plus 10 over our LCD of x plus 5 and x minus 3. We now see that they have the same denominators. We went ahead and figured out the new numerators, so we can write them as a single fraction all over x plus 5 times x minus 3. So I'm told to subtract. So x squared minus 3x, and when we subtract, remember, for polynomials, adding and subtracting polynomials, but this time for subtracting polynomials, we can think of this as a -1 and multiply -1 times 2x and times positive 10, or know that that minus sign changes the 2x to its opposite and the positive 10 to its opposite. However you think about it, it'll still get you a -2x and a -10. Alright, the next thing we need to do is clean it up a little. You always want to combine like terms. So we have x squared minus 5x minus 10 over x plus 5 times x minus 3. What I'd like to try to do here is maybe factor that numerator, but when looking at it, I don't think it's factorable. I'm thinking what times what makes 10. The only things I can think of are 5 and 2, but 5 and 2 won't give me a -5 if I add or subtract. And 10 times 1 makes 10, but 10 and 1, if I add or subtract them, won't make a 5. So this is not factorable. If it was, I would factor it and see if anything canceled out, but it doesn't, so we're done at this point. So that was adding and subtracting rational expressions with unlike denominators. Remember to find the LCD and then create new fractions based upon that LCD. Alright, if this video has helped you, please be sure to hit the like button, share with your friends, family members, fellow classmates, whoever needs extra help in this, and don't forget to subscribe. Feel free to shoot me an email if you have any topics that you would like a mini lecture made on. Take care and have a good one.